Hello everyone. In last lecture we have discussed what is alpha decay, and in today's lecture I am going to discuss theory of alpha decay. Okay, before going to start theory of alpha decay, let us recall what is alpha decay. That is radioactive nuclei with atomic number greater than 82, they spontaneously disintegrate because they are unstable nuclei. The process in which alpha particle is spontaneously emitted from unstable nucleus is called alpha decay. Okay, now let us see theory of alpha decay. The first point in theory of alpha decay is alpha decay occurs in such nuclei as a mean of reducing their size and increasing the stability of the resulting nuclei after the decay has occurred. Here in diagram we can see that on left side unstable parent nuclei, and on the right side a stable daughter nucleus and an alpha particle. The parent nuclei, which is having higher mass, then after emitting alpha particle its mass is reduced, so it becomes a stable nucleus. Here we can see that a daughter nucleus has reduced its size as compared to the parent nucleus. Okay, now let us see the next point. Here the next point is an alpha particle is emitted from a heavy nucleus as a discrete particle. This makes us to assume that some tightly bound system of two neutrons and two protons to free exist in the nucleus, or the nucleus to have substructure of alpha particle. Here you can see that this is the parent nuclei, and we are going to assume that alpha particle, that is two protons and two neutrons, combine to form alpha particle, which we need to assume that this alpha particle free exists in the parent nucleus. This is the second point. The second point is that alpha particle which contains two photons, two neutrons, which free exist in the parent nucleus. Okay, now let us see the next point. The next point is that a simple model for the potential energy of the alpha particle as a function of distance r from the center of heavy nucleus is as shown in figure 1. Here on right side we can see that daughter nucleus and alpha particle free exist in the parent nucleus, and these two nucleus are separated by distance r. Small r is equals to capital R. We know that when two positive charges brought side by side, then they repel each other. But here both daughter nucleus and alpha particle both are positively charged, and they should repel each other because positive charges repel each other. These two nucleus are positive charges because it consists of protons. Protons are positively charged. Instead of repulsion, they held together in parent nucleus. It is because of strong nuclear force. which is greater than Coulomb force. And also on right side we can see that a graph of potential energy U of r and distance small r is plotted. And here we can see that when a daughter and alpha particle are at a distance small r is equals to capital R, a strong nuclear force exists. This force holds these nucleus together. And also when this distance increases, that is when small r is greater than capital R, Coulomb force becomes greater. As distance between parent nucleus and daughter nucleus increases, then they separate each other. Okay, now let us see the next point. Here the next point is the attractive potential well associated with the strong nuclear force, and beyond range of this force an electrostatic repulsion due to the Coulomb force between the daughter nucleus and alpha particle is given by U of r is equals to 2 into z minus 2 e square divided by 4 pi epsilon naught into r, where r is the distance from the center of the nucleus and z is the atomic number of the parent nucleus and z minus 2 is the atomic number of the daughter nucleus. Here before going to study the above point, we need to recall one of the basic concept that we have studied in electrostatics, that is when two positive or two negative charges or one positive or negative charges separated by distance r, then the force between these two charges is given by F is equals to 1 over 4 pi epsilon naught into q1 into q2 divided by r square, and we can write this force in terms of energy, that is energy is equals to 1 by 4 pi epsilon naught into q1 q2 divided by r, or u is equals to k q1 q2 divided by r. The same concept here we are going to apply to nucleus. Here on left side we can see that daughter nucleus alpha particle which free exist in the parent nuclei and they are separated by distance a small r. So if we apply this concept to this nucleus, then we get that U of r is equals to 2 into z minus 2 into e square divided by 4 pi epsilon naught into r, where r is the distance between two nucleus, that is daughter nucleus and alpha particle. Z minus 2 is the atomic number of daughter nucleus and 2 is the atomic number of helium nucleus and E is the charge of helium and daughter nucleus, where 4 pi epsilon naught is the constant. Okay, now let us see the next point. The next point is, from classical point of view, an alpha particle does not have sufficient energy to escape from the potential well, and the barrier height is typically in the order of 30 MeV, and decayed alpha particles have energies only in the range 4 to 9 MeV. Classical argument failed to explain alpha decay but quantum mechanics provides straightforward explanation based upon the concept of tunneling, where particle can be found in a classical forbidden region. Here, from classical point of view, we consider alpha particle as a particle, that is helium nucleus as a particle, and if alpha particle want to separate from parent nucleus, it should have energy greater than 30 MeV, because this amount of energy this is the amount of energy exists between daughter and parent nucleus, but emitted alpha particle is having energy only 5 MeV, and this point is not explained on the basis of classical mechanics. Here we consider particle as a wave, and why 5 MeV alpha particle emits from parent nucleus. This entire concept is explained by quantum mechanics. Here we consider helium nucleus as a wave.